Hey everybody, we're back again with Mr. Monroe's Math here, talking about finding the number of cubes in now fractional edges of these rectangular prisms. So we want to be able to, for method one, back to that easier of the two, but we're going to have to do some conversions here. Determine the number of cubes that fit across the length, width, and height of a rectangular prism, and then using the formula of volume equals length, width, and height. So here we have fractional sides here. We're talking about method one, so of course we're going to take out our highlighter. This is an important method. We're going to have that there. So method one is talking about crossing out the sides here that we've talked about and trained you to do to find an easier method using the volume formula. So how many cubes if each cube is 1/4 inch by 1/4 inch by 1/4 inch? So again, back to our drawing, if we take that square and have this side length here, it's a really quick drawing. Each side is 1/4 and 1/4 and 1/4. So again, they're cubes. They're just like a dice that you roll out onto the table, whatever. So how many of those quarters go into these side lengths? Well, for 2 3/4, okay, you have the 3/4, which means you have 3 of them there, right? 3/4. So you have 3 of them. Now, what about the 2 whole? So for example, how many quarters are in $2? Well, that's 8. So if I have 8 plus the 3, that would be 11. We can also see that by multiplying and converting this into a fraction that is greater than 1. So 4 times 2 would be 8 plus 3 is 11, which means this would be 11 cubes going across. And so we could see that 2, 3, 6, 7, 8, 9, and 10, 11. So we could have 11 cubes going across like that. Okay, so just a quick little drawing example. The first row right there is going to look like that. Okay, what about a 1/2 centimeter? Well, a half can convert into fourths. We can multiply it by 2, which means it is 2/4. So there are going to be 2 of them for the width. So I have my 11, I have my 2, and now I have to have my height. So 1 1/4. Well, just like a dollar or an inch, how many quarters are in that? There'd be 4. So 4 times 1 is 4, plus 1 is 5. So in this spot here, we have 5 of those. Okay. So how many cubes in total exist in this area? Let's multiply it out. Okay. We got 5 times 2. That makes our 10. We like those groups of 10 because it's easier to multiply. All right. So we have 10. We have 11. What is 11 times 10? Well, it is, I love using my resources, 110 cubes that will go across like so. All right, so that's method one. What about method two? A little more involved, but this one works really well with the fractions here. Okay, so I have each cube worth 1/4 by 1/4 by 1/4, just like we've done before. I'll draw it again really quick for you guys. Okay, so we got 1/4 by 1/4 by 1/4. So you have that visual right there. Okay. So find the volume of the rectangular prism and the volume of each cube. Multiply the volume of the rectangular prism by the volume of each cube. So let's find the volume of this figure. We're going to use the exact same numbers as before. So this is 2 3/4 centimeters. This is 1/2 centimeters, and this is 1 1/4 centimeters. Looks like a little bit neater, so that way you guys can read it more legibly. So we're going to take these and find the actual volume. So the length, 2 3/4 times the width, which is 1/2, times the height, which is 1 1/4. And again, using our conversions, we want to find the values here and get them into fractions that are greater than 1. So this is equal to, well, 4 times 2 is 8, plus 3 is 11, so we get 11/4. Looks awfully familiar, doesn't it, up here? So 11/4. 1/2 will stay 1/2, and I'm going to use the multiplication symbol. And then 1 1/4 will become 5/4. So from here, I can multiply right across. 11 times 1 is 11. 11 times 5 is 55. Let's check down here. 4 times 4. And I can use the associative property, or commutative property, of multiplication here and use these factors as easier to multiply. 4 times 4 is 16, and then 16 times 2 would be 32. Okay? Or 4 times 2 is 8, and 8 times 4 is 32. So how many 32s come out of 55? Well, how many 52s come out of 35? That's going to be 1. And then how many are left over? Well, it looks like it's going to be 23. So we have that, and our volume is in centimeters, of course, so centimeters cubed, and that is our volume. Now from there we need to find the volume of each cube. Okay, we're actually going to go back to this number pretty soon and use that as our value. So each cube is 1/4 by 1/4 by 1/4. So careful if you're multiplying. We know ones are 1. 4 times 4. Be careful you don't say 8. Make sure it's 16. 4 times 4 is 16, and then 16 times 4 gives us 64. So each unit here has a volume of 1/64, and we're using centimeters cubed. So how do we do this? Well, we are going to take the volume of the original 55 over 32. We're going to multiply that by 1, divide it by 1 over 64. Okay, so then what do I do from here? Well, how many cubes are we going to get? Well, what we have to do, keep change, flip. This becomes 55 over 32, now multiplied because we changed these two things, and then we flip the fraction to be 64 over 1. Anything times 1 is itself. However, it looks like we can simplify these pretty well. 32 goes into both of those, so 32 into 32 one time, 32 into 64. Well, that's half of it, so that means it's going to go twice. 1 times 1 is 1. 55 times 2 is 110, and we have 110 cubes. And by finding that, we can also go back to our first method that also had 110 cubes. So using those fractions, making sure we are familiar with multiplying and dividing by fractions is one of the most important things. And if you go back to Module 2 and look on this YouTube account here, smash a like on this video and these other ones will pop up onto that. So I will leave you with this thought that as my new favorite color is glitter.